Hi everyone, I am Satnam Singh and welcome to Satnam Explains, a brand new YouTube channel dedicated to engineering. In this session, we will understand the key differences between throttling valve and needle valves. And by the end of this particular video, I hope you will get conversant with their functions, working principles, construction, and their applications. So let's begin with a quick clarification first. See, technically a needle valve is also a throttling valve only because both control flow by restricting the passage of fluid. Okay. So, however, in practice or in industrial terms, when we say throttling valve, we usually refer to larger control or globe type valves or butterfly valves, and which can help in regulating higher flow rates. While needle valves, they are meant for very fine and precise adjustments. Typically, they are installed in small bore or instrument lines. So in this comparison or in this particular video, we are going to discuss throttling valves in general versus precision needle valves. Let us understand what is throttling first. Let us take an example of a domestic faucet. When you open it fully, water flows freely. As you start closing it, the flow reduces. That's simply throttling. In industries, throttling involves is the process of regulating or restricting the flow of a fluid by partially closing the valve, which causes a significant pressure drop from the inlet to the outlet. Now, this is a method for controlling a fluid's flow rate or other parameters like pressure or temperature with a high pressure difference across the valve. Let's begin with throttling valve. As we have already discussed, a throttling valve regulates flow by partially opening or closing the passage. They are not like isolation valves that are designed for full open or closed positions. Instead, they adjust the fluid resistance to achieve desired flow or pressure. Now, what do you mean by fluid resistance? Let us take an example of this globe valve, which is controlled with the help of a hand wheel. The movement of this particular hand wheel will control the movement of disc, which in turn will control the resistance to the fluid. In the next slide, we are going to see the mechanism of this globe valve. Now, the types of throttling valve will include globe valve, butterfly valve, pinch valve, ball valve, diaphragm valve, and also needle valve should also be the part of this particular list, and specially designed control valves. Now, in this, this is an example of a pneumatic control valve, which is controlled or whose actuator is controlled with the help of pneumatic air. You may also see some motorized valves in this particular example. Okay. Throttling valve, they find their applications where continuous control of flow or pressure is required. So you can see throttling valves installed in process lines, utility lines, for example, feed water or cooling lines, etc. So here's the typical construction of a throttling or a globe valve. It consists of a hand wheel or an actuator, the stem, bonnet, the disc, the seal seat. This is the seal seat where actually the disc rests upon. And the other parts like flange, backing gland, gland bolt, stuffing box, gasket, and this is the fluid inlet. Let's understand the working mechanism of a throttling valve, globe valve in this case. I have created this 3D mechanism using Canva. I used multiple images to create this 3D working, and I hope it will give a basic understanding of the working behind the valve. So initially you can see that this particular disc of this globe valve is resting on the seat. Okay, so it is not allowing this fluid to pass through. And when the hand wheel is rotated, the stem lifts. As the disc moves away from the seat, the flow area increases and the pressure drop decreases. So in this particular way, the valve can therefore maintain a desired flow by balancing this pressure drop. Globe valves and certain butterfly or plug valves are typically used for throttling valves. Now let's move on to the needle valve. Needle valve, it also works on the same throttling principle, but it is used for fine and precise control. You can see in this diagram, this is a diagram of a typical needle valve. It's tapered needle-shaped plug. It fits into a narrow seat, allowing smooth and gradual variation in flow. And valve, they find their applications in instrumentation and hydraulic systems where precision matters more than volume. In process plants, you can find needle valves used in pressure transmitter manifolds, sampling systems, in impulse lines, and even you can see some needle valves, they are installed directly into the feed line. So we are going to see these particular things into the following slides. Here you can see the cross section of a needle valve. Basically, needle valve, they are very small valves, and most of the time they are manually operated. Rarely you will see a needle valve actuated or controlled with the help of pneumatic air or electric signals. Okay. So here you can see small body with a finely threaded stem, a pointed needle tip, and a seat or orifice. So this is the working mechanism of a needle valve. Again, I have tried to create this 3D mechanism using the Canva application. Okay. So as the needle is turned clockwise, it moves down to close the flow path. And the handle, when it is turned anti-clockwise, it lifts the needle, increasing the flow area. Now, because of its geometry, a needle valve can maintain steady microflow even under high pressure conditions. That's why it's common in hydraulic, pneumatic, and fuel lines where precision matters more than volume. On P&IDs, both valves have distinct symbols. Throttling or globe valve symbol shows a movable disc on the flow line. And these are some other types of throttling valves like butterfly valve. It is having this particular symbol on the P&ID. A ball valve is there, diaphragm with this particular circular symbol. It shows a diaphragm valve, globe valve, and I have also included the needle valve because basically it is also a part of a needle throttling valve. Sorry. And needle valves, they are represented on P&IDs with the help of these kind of symbols. Okay. Now let's see the actual representation of a needle valve and a throttling valve. In this, we are going to consider pressure control valve as an example of a throttling valve on the P&ID. Now here you can see that a pressure control valve, which is abbreviated as PCV, is installed on the main fluid line. The valve controls how much fluid flows through the pipeline and keeps the pressure steady. Now look at the needle valve, which is inside a red rectangle. It is installed in the thin pipe connected to the PCV. This particular pipe is known as the impulse line. You can see that needle valve is connecting the upstream of the PCV to the downstream of the PCV. Now, what is the benefit of this? By slightly opening or closing the needle valve, we can slowly balance the pressure on both sides. This helps the PCV open and close smoothly, prevents sudden pressure jumps, and lets the operator adjust how quickly or smoothly the valve responds. Okay, I hope it is clear to you. This is a different P&ID, and I have considered it because in this P&ID you can see that there are two needle valves. They are installed directly on the feed lines, and these needle valves, they are actually controlling the lube oil supply to the bearing of the motors. Okay, so why I have included this because I just wanted to show you that needle valve can have various applications, but the only principle is, or the only thing why they are installed, they are only installed to get precise control of the flow of any fluid that we are that is under consideration. Okay. This is a flow characteristic curve for both the valves. This graph compares valve opening versus flow rate. A throttling valve generally follows an equal percentage curve, meaning at low openings, small changes cause small flow variation, but at higher openings, the flow increases sharply. On the other side, a needle valve, however, behaves more linearly. The flow rises almost proportionally with the stem movement. So that's why throttling valves are great for wide range control, while needle valves, they provide stability at very low flows. So in this graph, you can see the blue line, it depicts the control valve or the throttling valve that we have been discussing. And the orange line, it is showing the curve for a needle valve. Finally, let us compare the material and pressure ratings also. Function we have already discussed that throttling valve, they are mainly used to flow control in process lines, and needle valve, they are used for precision flow control in small bore. Throttling valve or globe valve or any other valve that is used for throttling process, it can come in various sizes. They can range from half inch to 24 inch. On the contrary, needle valve, they are of very small, you can say openings, 1 by 8 inch to 2 inches. And throttling valves, they are usually made from CS, carbon steel, SS, stainless steel or alloy steel with ratings up to NSI class 2500. However, needle valves, they are mostly made of stainless steel or brass with pressure ratings from up to 6000 psi per square inch in SS and 3000 psi for brass. Other parameters, they include the temperature range for throttling. It can range up to 650 degrees centigrades, and for needle valve, it is up to 400 degrees centigrades. Flow is medium to high for throttling. For needle, it is low or micro flow. Operation, throttling valves can be operated manually. We have already seen that a globe valve can be operated with the help of a hand wheel. However, they can be actuated with the help of an actuator, and actuators can be actuated with various, you can say, uh, things like pneumatic air, or they can be motorized control also. Needle valve, they are manually operated, but yes, you can see some applications or see some types of needle valve that are controlled with the help of pneumatic air or electrical signals also, but they are very rare. Most of the time, needle valves, as they are used for precision control, they are manually operated only. So to summarize, both throttling and needle valves, they regulate flow, but they serve different purposes. Throttling valves control the main process flow and pressure across large systems, while needle valves, they provide precise, small-scale control in instrumentation and calibration circuits. So choosing the right valve ensures efficiency, accuracy, and system reliability. Thanks for watching. If you found this explanation useful, please like the video and subscribe to Satnam Explains for more engineering insights. I have created this channel with a clear purpose to share valuable knowledge on process engineering, instrumentation, and process safety. Your feedback and suggestions will truly help me improve and cover topics that matter most to you. So feel free to share your thoughts in the comments below, and I would love to hear from you. Thank you, and thanks once again. Thank you.